Assalamualaikum warahmatullahi wabarakatuh and good morning.
Salam sir.
Good morning, sir.
Section 2 Tiga, 30, 53. Okay, yang ada 49 ni including me kan. Okay lah Okay. Alright. Can you see my screen?
Yes, sir.
Yes sir. Yes sir.
Okay, so before we start so this is one simple video I would like you guys to watch sekejap je ni.
Behind all of the software that we use on a daily basis, there's a code being run with all sorts of different terms and symbols. Surprisingly, it can often be broken down into three simple programming structures called sequences, selections, and loops. These come together to form the most basic instructions and algorithms for all sorts of software. A sequence is a series of actions that are completed in a specific order. Action 1 is performed, then action 2, then 3, etc. until all of the actions in the sequence have been carried out. A sequence we do every day is a morning routine. You might wake up, drink some water, take a shower, eat breakfast, and so on. Everyone's routine is different, but they're all made up of a sequence of various actions. Selections are a bit different. Instead of following a specific order of events, they ask a question in order to figure out which path to take next. Let's say you go to brush your teeth and you find that you're out of toothpaste. You then ask, do I have any more toothpaste? If the answer is no, then you would add it to your shopping list. But if the answer is yes, then you would just use the toothpaste. This is really all a selection is doing, answering a question based on what it finds. The third programming structure is a loop. Like selections, loops also ask questions. However, the difference is they ask the same question over and over and over again until a certain task is complete. For example, take the act of hammering a nail. Even though you may not realize it, you're constantly asking yourself, is the nail all the way in? When the answer is no, you hammer the nail again. You continue to repeat this question until the answer is yes, and then you stop. Loops allow programmers to efficiently code repetitive tasks instead of having to write the same actions over and over again. These three programming structures may seem fairly simple on their own, but when combined, they can create some pretty complex software.
Okay. If you remember our syllabus so we have three basic logic structure that explained by the video So first we have sequential logic structure, okay, sequence then we have decision, and then we have looping. Okay. So today we are going to cover on the sequential logic structure. Okay, if you can finish everything by today, then we can move much faster okay. Otherwise, we are going to cover half, and then next week we cover another half because actually this is a very basic of the programming logic and very easy to understand hopefully everyone can will not have any problem with these topics Do you hear any noise?
No, sir.
No sir.
Tak ada kipas saya ni bising pula kat rumah ni. Kalau tak dengar tak. Kalau tak ada apa okey lah. Okay, alright. So let's go to the slides. Right. So basically, in this topic, as you can see over here kan, so we have PAC, IC, IPO ni kan, and then pseudocode and algorithm, dash checking and flowchart. So this is not exclusive for this topic only, okay, not only for sequential logic structure, but it is applicable to all three logic structure, okay. So when we go to the chapter 4 decision logic structure and chapter 5 loop logic structure, we still have to use all these elements. Okay, this is a standard design procedure lah. So what is the relationship between all these elements with the program design? So I show you the general general linkage. Okay, the relationship. So in general, okay, programming or program can be developed either using module, okay, module structure. Okay, module is when a program contains more than one function. We call it function lah. Function ni I already explain kan, a little bit about function kan. The one we already covered in chapter 2 is the built-in function kan. The function that we obtain from the library kan, from the programming for example C library kan, C++ library. So we obtain the function from that particular library. So this is what we call as built-in function. The function over here, however, is not built-in function. So this is a user-defined function. Okay, user-defined function. Okay, where we as a programmer develop our own function. Okay, so we call this structure as a module lah. So a program can have more than one module, okay, meaning that it can have more than one function, user-defined function, okay, or a program can be developed by using a non-module concept. Non-module ni without module lah, okay. So no module at all, meaning that we have only one function for the whole program, one function. What is a function in this non-module? Okay, we have only one main function. Main function is compulsory for all computer program. Whether it is module or non-module, both must have main function. So main function is not user-defined function. It is main function. Okay, all program must have it. Okay, so how does it related to this PAC, IC, IPO? Okay, so PAC, okay, when we develop a program, okay, PAC is needed lah. PAC is where we define where we analyze the problem, okay, to obtain important information, okay, such as variables kan, such as operator ke involved, such as ada decision ke, do we need looping, do we need which variable should be input, which variable should be inside of equation, which variable should be become as the outputs of the program. So all this, okay, we analyze by using the PAC. So it looks like doesn't matter whether our program is module or non-module, PAC is required, okay, as a first step of program development. Okay, understand? Okay, then after PAC ni, so we have this IC, okay, IC and IPO. So IC and IPO, okay, most of the time, I'm saying this most of the time, but it's possibly needed or not needed. Most of the time it is needed. Okay, when the program is a module structure. Okay, we have user-defined function inside of our program. So we apply IC and IPO. Okay, so IC and IPO shows the relationship of each of the modules inside of a program. Okay, each of the user-defined function inside of the program. Okay, defined by the IC and IPO. So this is if the program is module lah. Module. Okay. Then we have pseudocode, algorithm, and flowchart. So this is actually in the same hierarchy. I'm saying that it is the same hierarchy because most of the time we only apply one. Okay, either pseudocode or algorithm or flowchart. Okay, we can see that this is the almost final design of the algorithm lah. So either pseudocode, algorithm, or flowchart. Okay, most of the time we didn't use all three. Okay, we choose either one. Which one to use? Okay, and then after that, specifically for algorithm, specifically for algorithm, we have dash checking. Okay, we have dash checking. Dash check. This is only for the algorithm. So what does dash check does kan? Dash check will check whether the algorithm is correct or not. Okay, so this is used to verify algorithm only, not pseudocode and flowchart. Okay, only to verify the algorithm. Dash check. Okay, so that's the relationship between all these items lah. This one Okay. Okay, pseudocode, algorithm, and flowchart, they all can be module or non-module. Okay, so module or non-module must use the structure, the design is going to be different, but we can use either three of these, either one of these, these three. Okay, boleh? So this is just to let you guys know the relationship between this. Otherwise nanti you wonder kan, so why do we need PAC? Why do we need IC, IPO? And where we need to apply kan? So basically this is the earlier part of program development. PAC very simple class. The concept is very simple. Don't worry. Okay, so as you can see from the video the earlier video, so sequential logic structure is process that is very sequence very linear we say, without having to make any decision, without having to looping and nothing like that. So a program can have a sequence of just input just input, that's all kan, or it can have just output, okay, or it can have a combination of input and output only kan, or it can be a combination of input, calculation and output, something like that. Okay, that one is sequence. All right. So we are going to start with the PAC, IC and IPO. Okay, so how to develop the PAC? Okay, so PAC. Okay, so first before we develop the PAC, you need to separate the information that you get. Okay, the problem that you get from your client, you need to extract the information and divide it, bukan divide kan, differentiate it, whether it is a input, output or processing. Input lah kan. Input, how do you determine input? Input can be from two sources. First, the input come from user, the user of your program. Okay, so how do you want to make sure that that particular information is input from user? So basically, when you run the program and user need to enter something to the keyboard kan, enter kan. For example, user enter number 1 or user enter name kan. So automatically name is going to be an input to the system. Input from user. Okay. So another thing is input from the program itself. The program generate the input. So nanti we are going to look at how the program generate input kan. Okay. Okay, but the important part over here is the program, the input that obtained from the user lah. Okay, that's the main our main concern in the PAC. In the PAC, input obtained from the user. Okay, output lah. So how we recognize the variable, for example kan, is an output, not an input. Okay, output is our concern. Okay, is the data that user can view from their screen. Okay, so that is considered as output lah. Of course, if the system involving no screen system kan, for example robotic system kan, so the output is in the form of apa, gear kan, gear movement, itulah, that one is output also kan, or maybe voice kan, that one output. But in here, okay, the one that we are going to cover is the output is anything that user can see from their computer screen lah, because we are designing a very basic program kan, program yang only user can see from the screen only not other source of output device kan. Okay, so a variable kan, a variable can be input, only input, or a variable can be output, or a variable can be both input and output. For example, variable name kan. So user need to enter their name to the, for example, to the ecom kan, ecom UMP system kan. So user need to enter their name. For example, my name Zafril. And then at the end of the program, the ecom will display my name to the screen. Okay, after I input Zafril, that one variable name become an input, and then at the end of the program ecom, it will pop up the name to the screen, to my monitor screen, laptop screen. So name also become output. So variable can be input, or it can be input and output. Right? Yeah. So processing is in the sequential, so processing that involved is only if the program have a calculation on it. This is we are talking about sequential logic structure. What should we categorize as processing? If a program, if a problem, the program that we want to design for that particular problem have a calculation on it. It doesn't matter whether equation or expression. So we put it and we categorize that as a processing required lah. Okay? Clear class Very simple simple concept Okay, so how to develop a PAC? Basically PAC ni so consists of this these 4 elements. The given data, which is the input, required result, output, processing involved, calculation, solution, list of solution, alternative. Anything. I say anything Okay, anything that required. I show you some of the example. Okay, any other information, you put it list of solution and alternative. Okay, so what PSC looks like? This is very basic, class. As you can see, if the question asks you to develop a PSC for the case study below, kan? So what you should do? You should construct this table consists of 4 sections, kan? So this is the input, given data. This is the output. The output. So this is the calculation involved. Okay. And then this is the solution alternative. Example. Okay, so develop a program that require that able to find the average of 5 numbers. Okay, using sequential logic structure. Sequence logic structure, kan? If using a loop logic structure, the design is going to be different. This is sequential logic structure. So what should be the PAC? 5 number, kan? So logically, when you want to develop a program to calculate average of 5 number, how many inputs should user enter? How many input?
5.
Exactly 5, kan? So exactly 5 numbers. So you must have 5 variable. Okay, 5 different variable. So remember the rules to name a variable. So you must follow the rules how to name the variable, kan? Okay, for me, I prefer you to put the variable that is a formal variable inside of this table. Okay, for example, formal variable couldn't have space, okay, in between the variable, cannot end. So I prefer you do the formal variable naming. Okay, alright. Okay, given data is the input. Okay, so the input is 5 number, kan? Doesn't matter lah if you want to put the name as what, apa, no 1 ke, no 2 pun boleh, kan? Pun boleh, It's up to you as long as it follows the rules of naming variable, kan? It should be understandable, kan? That one is first, kan? No 1, we know lah that one is number 1, kan? No problem, boleh, So this is input. So the outputs, okay. This could be sometimes could be tricky, because it is based on the requirement of the question. If the question doesn't state what should be the outputs, then you can put the final result. Okay, the average, kan? Average of 5 number. If you just put average, okay, pun boleh, average, So this is formal variable name. So I prefer formal variable name boleh, macam ni. Clear. Nanti when we go to the next step, it's going to be much easier to extract the information from PSC and move it to the IPO algorithm, flowchart and so on, if we use standard variable name. Okay, but let's say the question asks you to find average of 5 number and display the result, the total, for example, total display total and total inputs and average. So what's going to be the required result, class? How many required results over here? Is it remain as 1 or we should add more?
More.
Add more.
More, how many?
3.
Exactly. Exactly three. Three
Yes.
variables. Average, and then what?
Input and average.
Input.
Total.
Total.
Total. Betul.
Betul.
Okay, if you put it like this, okay, you got only two correct. Average and total.
Must put number 1, 2, 3, 4, and 5.
Yes, correct.
Average total.
Okay, you should be specific. What input kan? Input as I said kan, not all inputs should be as the output kan, based on situation and based on the requirement. So in this case, all the inputs. So all the inputs, what are the inputs kan? So you need to list down all the inputs. Dia banyak copy and paste PAC, IPO, IC ni copy and paste kan. Macam tu kan. Bukan so this is the required result. 1, 2, 3, 4, 5, 6, 7. Okay, 7 element. If the question specifically mention this element, display the total inputs and average. But if doesn't mention this, then it goes back to this goes back to the original version. Doesn't mention what should be the output. Okay, the question doesn't mention what should be the output, so you are free to design your program outputs. Alright. Understand? Okay. Next is the calculation. So we put all the calculation. Okay, all the calculation. If let's say your program have 10 equation, so list all the equation. Okay, for example, this is the first equation. Okay, to get the sum of 5 numbers, and then to do the division kan. Okay, so alternatively you can combine. Okay, if you may combine the equation pun boleh kan. So for example, combine this one. How we want to combine these two equation? Macam mana kelas? Kita okay. Bracket kan. Make sure the equation is standard computing equation Okay, this is also acceptable. This is average bukan total Okay, make sure it is standard computing equation. This is also acceptable. Right? So either one is correct. Okay. And lastly is solution alternative. Okay, solution alternative, you need to put something over here kan. But usually sequential logic structure, nothing much you can put kan. So you may put something like this. Okay, define the inputs. For example, inputs not numbers inputs as constant. And then alternatively, you may define the inputs as input value, meaning that it is not constant. Macam mana you nak buat ayat tak kisahlah as long as you put something over here. And then you put star, meaning that this is the solution that you are going to use. Okay, you have two alternative way to design this program. Okay, first you can define the numbers as constant, and then you may define the numbers as normal variable kan. So in this case you choose it to be the second because you want the program to be able to change the value of number 1, number 2, number 3, number 4, number 5 for whatever reason then. Okay, so this is standard. So first, if you don't know what to put in the solution alternative, put something like this. Okay, constant and input value, and then put the star. Star meaning that the alternative that we choose. Okay, from these two. Boleh kelas? Okay, so this is another problem. Okay, so what's the PAC kan? A program is required to find the volume of a cube. Okay, again, it doesn't specifically mention anything kan, the input ke, the output ke, so you are free to design your program macam mana pun kan. Alright, so given data is the input lah. So how to calculate cube? Cube punya volume kan, volume tu apa? Panjang, lebar, darab, tinggi kan. Okay, sebab cube, for cube the apa panggil tu, panjang, tinggi, lebar dia sama kan, is similar kan. Okay, okay, the age lah. Okay, age is similar for all the three. Okay, so we just put it as age lah, because the value is similar kan for cube kan. Kalau if it is segi empat, lupa dah apa nama tu, segi empat tak tepat tu kan. Itu the input is going to be 3 different input lah kan. Okay, first age, second age, third age, to calculate the volume kan. But in this case it is a cube, so it is similar age kan. So just input 1, which is age. Okay, cover all 3 kan. And then required result. Okay, volume. Okay, if you want to make it official variable name, just put volume lah. Okay, I prefer this simple Okay, straightforward but meaningful lah. Okay, make sure it is a meaningful variable name. Okay, alright, and processing required. Okay, processing required is the equation. And solution alternative, okay, you may put like this. Define the age as constant, define the age as input value. And then put a star in front of the input value if you want age to become normal variable. Okay, normal variable is the value can be changed throughout the program kan. Remember this kan, constant, the value cannot be changed throughout the program running. Okay, class PAC, very simple so I consider this as a free marks, bonus mark. Okay, and it will appear in the test. In the test, maybe in the final, this is a must question. Alright, so this is a PAC. So where did it reside in the program development process is first. Okay, first we get the problem, we construct the PAC table. Okay, next is next is the IC. Again, this is IC also very simple. IC is when, okay, macam ni kan, I explained earlier kan. IC is when our program is designed using a module concept, where we have more than one modules in a program. So we want to list all the possible modules in our program, where we want to list all these possible modules inside of IC. At this point kan, we are not yet designed the complete structure of the program. We just we just briefly think, oh, what should be the module instead of my program. Okay, list down all possible module. Okay, list down all possible module. So where we want to list down all these possible module? Inside of the IC. Okay. Right. So basically, what you should do in a IC. So IC can be divided to procedural programming or object-oriented programming based on the design of your IC. But in this class, we are going to use procedural programming. OOP ni, this is a different subject. This is so much more to cover. So we are not going to discuss this in this subject. We are going to use procedural programming. Okay, standard procedural programming. Okay, which is top-down method. So macam mana kan? Okay, this is the basic of IC. Okay, so you must put a control. Okay, control and number ni. Usually I don't use the number ni lah. Okay, this is optional lah. But if the question asks you to put number, then you need to put number. Okay. So control module, mainly we name we put control along with the program name. Okay, for example, program to calculate average. Kan tadi kan? So we put average control. Okay, this is just to indicate that this is the module, the main module. Okay, the main module that control everything. For example, kan? And then we have, let's say we have first module. Okay, what should be the module? If you couldn't find, if you want to develop a program that is module kan, bukan non-module kan, module, okay, that apply module on it, but you couldn't think what module should I put in my program kan? So just go for the basic module, which is input. Okay, input module. Okay, we put it as the first kan, because most of the time when we run a program, we read the inputs first. Rarely program give you output kan. Macam mana nak dapat output kan if you didn't have the input and calculation kan. So normally when you run a program, first module it will go is the input module. Okay, that's why we put 1. So meaning that this is a okay, highly possible to be execute first. Okay, and then what is the generic module kan? What is generic function kan? This is function lah. Module, when I talk about module kan, module or function, it is the same thing. Kadang saya guna function kadang saya guna module, but it is actually the same thing. Okay, so generic module or function is calculate. I'm saying this as generic. Sometimes a program doesn't have any calculation kan, so no module calculate lah. Okay. Okay, if there's calculation then you put all the not all you put the necessary calculation inside of this module. Okay, so generic display or print module kan, for example print module. This is for the output module. So any outputs you have, maybe you can put it in the output module. This is just remember this is if your program is design involving a module. If no, then we doesn't have we doesn't have to use IC at all. This is only for a module types of program design. Okay, so this is additional. Okay, additional, maybe we have sub module. If you don't have sub module, then you can delete. You can delete this one. You may delete these two if you don't have sub module. Okay, what is a sub module? Sub module, if you have another module inside of the existing module. For example, this is apa example lah kan, calculate. Inside of this you have calculate one module and then this one you have maybe you have calculate 2 module that you need to differentiate. Boleh you can put it like this. Okay, so you can see the number. Okay, 2 1 because it is belong to 2 module. Okay, the number kan 2 1. This is 2 2. Alright, in general it is something like this, but in this class most of the time the thing that we design is something like this this is the generic. Generic is like this. If you put it in your answer, you got full marks already. Okay, generic if you put just like this you got full mark already simple kan. You don't know what to put kan, pecah kepala fikir kan masa exam kan, so just put this in your answer and then it's okay, you got the full marks most of the time lah based on question juga, but most of the time this is the answer in the schema Okay, easy easy or not class? Boleh? Any question?
Boleh.
Boleh sir.
Boleh sir.
Okay. So this is a much more complex design. Okay, when I say complex it is up to you lah. If you want to design a complex program, it's up to you kan. But if you want to design very straightforward kan, it's also up to you kan, as long as you answer the question kan. But let's say you need to come up with a program that require you to have decision and looping. Okay, decision and looping in the module dia lain decision and looping involving module lain, decision and looping involving other than module tu lain nanti jangan pening, we are going to discuss that further in the following chapter decision looping tu kan. But in case let's say that you need to put some element of decision in your IC, in your IC. So what can you do is you must use this symbol. Let's say inside of module 2 there are a process that you need your system need to be done. So if the process is true, it will go to model 4. If the process is false, it will go to module 5. For example whatever the decision is, so you need to put the diamond symbol, meaning that instead of it will go to all the module, it will only select one module based on the question you put over here. Understand? If you put this symbol, meaning that it will only execute either module 4 or module 5. If you don't have this symbol, meaning that the program will go to all the module, module 4 and module 5. If you put this symbol, it will only choose either one. Understand? This symbol this is a decision symbol. Alright. This symbol, if your design involve repeating a certain module, a specific module, the lain program that repeat all the modules, or a program that only repeat a specific module. Okay, in this case, the program only repeat module 3. So you put a circle on top of module 3. So let's say if the program required to repeat module 2 and module 3. So you put ni lah. Double dot lah. In module 2 as well. So it repeat module 2 and repeat module 3. Okay? Okay. If the module is actually the same repeated module, but for whatever reason, you need to put twice in your design, kan? Okay. So you put it over here and mark it at the edge of bucu ni kan, of the module. Okay, meaning that this module and this module is exactly the same module. For example, input module tadi kan. So if this is input module, okay, this supposed to be what class? Module 4 should be
Input.
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 be input as well lah. Okay. Alright, it is duplicate. Duplicate. This is the symbol of duplicate. Okay. So this is a much more complicated IC. Alright. But you need to have a reason for you to put this one, this one, this one. If not needed, then just stick to this design, basic design. Okay. Okay, so if you use, for example, you use, you need to put repetition, okay, to this end. So you need to put some notes over here, okay. Repeat until no more subjects. For example, user enter 5 subjects, kan. So it will repeat read and calculate 5 times. So you need to put some indicator over here, okay. Until no numbers. If you want to if for example you want to calculate 5 numbers using looping, okay, not using sequence, not using sequential, sequential, no looping, ni looping until no numbers. For example, you want to calculate 5 numbers using looping, kan. So you may put it like this. So it will repeat 5 times. Okay, it will enter 5 times over here and it will calculate 5 number over here. Calculate. Okay, if user enter 1 number and then it will add the number with 0. And then user enter number 2. So it will add number 2 with number 1. Okay, and then user enter number 3. It will add number 1, number 2, number 3. That's why we put it like this. If you want to design a program like that. Okay, print no loop, kan? Because we print only 1. Okay, we print only, for example, the total tuition fees only. Okay, we only consider the final value of the total, kan? Not the accumulation of each of the looping, kan? No, the final accumulation. That's why we put 1. But let's say, for whatever reason, kan, you want your program to print all the accumulation, kan? Kan, number 1 plus number 2 you want to print. Number 1, number 2 plus number 3 you want to print. Number 1, number 2, number 3 plus number 4 you want to print, kan. You want to print all the output, kan. For whatever reason, kan. Ni nak copy ni, kan. So you must put dot. Tak boleh nak copy pula dot ni. So you must copy, you must put dot over here lah if you want to design your program to repeat its module. Okay, repeating a module. I'm saying repeating a module. Boleh ke lah? Understand? Okay, so this is another example. So this is optional. So maybe you can have this, maybe you don't have to have this. Just a basic read, calculate, print, it's okay already. But let's say you need to have level for whatever reason, this is how you do it level subject kan. Okay, so this is a procedural programming that we are going to use throughout the semester. Okay, and this is example. I'm saying the example kan. Example, if it is a IC of OOP design. So OOP ni, object oriented programming, it doesn't have any specific structure. Okay, so the module can be connected with any other module. You know, the design is quite messy but it is object-oriented programming. There's a reason for this. But just to show you that for OOP, there's no specific structure, something like this. No. Okay, over here we put read as 100 because we consider it as a the most important module. Bukan most important kan, the module that we want to execute first kan. But if you see from here, although this is module 1, not necessarily that we are going to execute module 1 first. You see, there's no specific hierarchy. Okay, for OOP. Okay, or you may design the OP like this. Okay, something like this. Or maybe this one can have arrow over here kan. Arrow. Boleh kan, tak ada masalah OP okay. Okay, so done IC very simple. This is the basic IC. So next we are moving on to the next element, which is the IPO. Okay, so where is IPO in our design phase kan? Over here okay. If you are applying module design structure, okay, a structure involving a function, then you must use IPO Okay, so IPO okay, so basically IPO is the ni kan, the details of the PAC. The earlier PAC tu, we detail it up on the IPO. Okay, let's have a look at IPO design. So this is IPO, consists of table of 4 section. Tadi kalau PAC kan, the section is lain kan. The section is like this kan, 4 section. Okay, for IPO don't get confused with this So IPO is like this. So this is the input. Okay, similar as PAC kan. PAC we have input over here, which we didn't call as input kan. Okay, in PAC we define it input as a given data. Don't ask me why we didn't use input over here kan. The format is given data kan. Okay, given data may be input, maybe not. Okay, nanti kita tengok apa contoh given data yang bukan input Okay, but over here specifically for IPO, specifically we put input. Okay, this is where we put the input variable. Okay, processing. Okay, if here in the PAC, processing required, mainly we put equation. Okay, but in IPO, okay, processing is all the process. Input process, calculation process, looping process, decision process, output process, everything we put it in processing IPO. Okay, module reference. Okay, module is the module that we have. Okay, in this case, let's say we have module read, or module calculate, or module print. That's what it means by module And tuition fees control, for example, control. So over here we have 4 module. 1, 2, 3, 4. So we put it somewhere in this section. Okay, output lah. Output is only output lah. So where do you get this? In the PAC, we obtain it over here. So you may copy volume, for example, kan, required result is the output kan. So copy the volume variable, okay, variable and put it in the output section. Okay, that one is transfer from PAC to IPO. Okay, you see the ni the apa dia punya flow tu kan. Alright, example. Example how to develop the IPO. Very simple kan. We have a problem that you need to design for the solution, computer solution. Calculate fees of a student in a tuition center. Okay, user need to enter lah, insert ni enter sama lah. Insert, enter, input. Okay, the keyword for input process So you need to know the keyword User need to insert kan. User need to insert. Meaning that this is the input process kan. So what comes next should be the inputs lah. Insert level of study. So level of study is the inputs. Okay. Level of study is the input. Okay, 1 for UPSR, 2 PT3, 3 SPM, 4 STPM. Okay, most common mistakes that student did during their design is they are putting input, not level Level pun kadang-kadang dia letak, but they also put UPSR, PT3, SPM, STPM. This is common mistake. You see? Why is it wrong, class? To put UPSR, PT3, SPM, STPM as inputs. Why is it wrong? Any idea?
The user will insert the number 1, 2, 3, 4.
1, 2, 3, 4. Okay. That comes to the next mistake. Macam mana nak besarkan ni? Tak boleh. Okay. Okay, if this is wrong, some of you also put it something like this kan. 1, 2, 3, 4. Every semester I will see this kind of answer in your assessment 1, 2, 3, 4. Is this correct or wrong, class? If I put 1, 2, 3, 4.
Wrong.
Why is it wrong?
Because it doesn't specify which level the 1, 2, 3, 4 is.
Okay. Any other answer? We focus on the input first. Why 1, 2, 3, 4 or UPSR, PT3, SPM, STPM is wrong?
Boleh berubah.
Boleh berubah, okay. Okay, boleh berubah. Lagi ada jawapan lain?
Because it's constant.
Constant, okay. Betul? Lagi? Okay, because this is a value. This is the value of level. Okay, level can be 1, can be 2, can be 3, can be 4 kan? Betul guys? So 1 for UPSR, 2 for PT3, 3 for SPM and so on kan? It is a value class. Okay? We are not concerned about value. Over here we only concerned about the what class? Not value but the variable. So just put the variable only. Okay, not the value The value is when we are running the program. But in this case, in this phase, okay, we are concerning about the variable that holds the value, not the value. Okay, not the value, but the variable that holds the value. So what holds 1, 2, 3 and 4? Level kan? So we put level lah. Don't put the value put the variable Okay. And subjects. Okay, this is also the same lah. Don't put 1, 2, 3, 4. Don't put BM, BI, Math, Science Wrong Put the variable that holds this value. So the variable is subject. Alright. Okay. Okay, so when we we already, okay, this is actually taken from the PhD lah. So PhD yang kita kena pecah kepala nak fikir kan, apa input kan, what should be the input. In PIO, in IPO, we just extract the input that we obtain from the PhD and put it in the IPO table. Okay, after we put all the necessary input, then we elaborate what are the processing involved. Okay, so first, okay, this should be in line. Level is used for input process kan. So the keyword for input process, you must put it something like this. It can be enter, it can be input, any keyword that when people read, people know that this is input process. Okay, you see this one, is this input class? Is this input?
No.
Calculate kan, calculate not input process kan, so you know kan, immediately you know. Is this input process?
No.
No.
No kan, so you know. Okay, so processing must be based on the variable and also the flow. Okay, over here is actually we are designing the flow of our program. Okay, you see from input, okay, this is required input, and then after input we do calculation. Okay, so calculation, you may put calculate fees, or you may put the equation that you get from the PhD. For example, this one, just copy the equation and paste it over here. Okay, paste the equation kat sini kan. Pun boleh paste the equation kat sini. Same if you put equation, when people read, people know that this is a calculation process. Okay, example kan, fees. Contoh ini tak habis lagi kan dia punya ni. Fees, level plus subject. Example example. Kan. Okay, pun boleh you put equation. Okay, or simply calculate fees kan. And then you need to specify, okay, each of the process maybe belong to what module. Okay, as I said earlier kan, we are designing IPO. If we want our program to apply module structure kan, we have more than one modules in our program, then we need to construct the IPO. Right, so module reference is the name of the module that you define in the IC. IC. This one If you define 3, so just use this name, exact name, kan? Calculate, read, calculate, print. If you use CALC lah, the name of the module kan. Okay, so possible, let's say if you use input over here kan, example, input module. Alright, so over here should be apa class?
Input.
Input lah. Input. You cannot use read because you are referring in what module kan? You are referring to input module. Exactly the name, similar name that you define in IC. Alright. So this can be put in input. This can be put in input module. Okay, the equation we may put in calculate module. Okay, print fees we may put in the print module. Okay, so over here, you see, there's a variable over here. So this variable, if it is involving in the display processing, you put it in the output section. Okay, so this is similar with the data that you put in required result of PAC. Okay, so kalau ada fees kat sini, so ambil fees ni, okay, take the fees and put it in the IPO. So it should be tally with the required result data. Boleh kelas? Okay. As you can see, calculate no output over here because calculation user cannot see the output yet. Okay, calculation involved in the computer CPU kan, for example kan. So user cannot see the process kan. User cannot see the process of calculation. What user can see is the output value. So how we want user to see the output value? By putting this process lah. Baru user boleh nampak. Ini user cannot see calculate. That's why no nothing over here. This one also nothing for input. User cannot see User enter the input kan, not user see the input kan. User the one that input the value. So we put it over here. Calculation nothing. Print baru ada variable. And lastly, you need to put an end to the process. Okay. So when we end the process of a program involve more than one modules, okay, the compiler will return back to the main module. So you put the main module name over here. Kan main module tadi, it should have the program name follows by control so that we know that this is the main module. So where do you get this? In the IC. Okay, for example, over here kan, tuition fees control. This is what you put in the IPO end. Okay, end of the IPO process. So you put this variable, this module name. Any question, class? Boleh tak? Mana tadi? Okay, ni kan. Any question?
No, sir.
No, sir.
No, sir.
Kita habis awal sikit hari ni Habis IPO ni Kita stop dulu lah. Boleh sambung banding pantai Okay, let's look at another example. This one is calculate average of 3 numbers kan. Okay, bear in mind that we are in the chapter 3, sequence logic structure kan. So we are not applying any looping or decision yet. That's why you see we have a repetition process kan. Number 1, number 2, number 3. Imagine calculate average of 100 numbers using sequential logic structure. So how many inputs should I put class over here? Specific using sequential logic structure. How many input class? How many variables should I put over here? How many?
100.
Exactly 100 kan? Okay, exactly 100. Number 1, number 2, number 3, number 4, number 5 until number 100. Okay, if we apply sequential logic structure kan? Sequential same goes to the processing lah. So enter number 1, enter number 2, enter number 3 until enter number 100. Okay. Okay, this is same if you are using read in your IC design, okay, earlier IC, so use read. If you use input, use input. Okay, so this is you see, this is another example that use just copy and paste the equation that you have in the PAC and put it over here. Or you may just put calculate average sahaja pun boleh kan. Okay, module reference, calculate, and then print the average. Okay, print, there's output over here, output variable, only for the output process, output process. So let's say if you have another process over here, for example print, for whatever reason you want to print number 1. Okay, what else should I add over here class? Module reference, should I add anything in module reference? If I add print number 1 in the process? Module reference, what should I add in module reference?
Print.
You need to correct kan? You need to put one more print over here. Right? Anything else should I put in the table?
Output.
Output, correct. Okay. So over here, number 1. Okay, understand class
Yes, sir.
Okay, let's have a look at one more example over here. Okay, write a PAC to find area of triangle. Ni bukan PAC lah, right? PAC IC IPO to find an area of triangle. This is given the equation as well Senang hidup kalau dia bagi equation kan. Otherwise you need to think of the equation by yourself Oh, dah ada kat sini ada IC and input processing. Okay. Alright. Area of triangle. Okay. Area of triangle. So to calculate area of triangle, you need to have height and length as the input. Okay. Height and length as the input. And then since the question doesn't specify what should be the output, okay, as we discussed earlier, you may put the final output as the output. Otherwise, if the question specifically tells you to print area, height and length, okay, so you need to add area, height, length, okay. If kan, something like this kan, and print area something like that kan. Specifically mention that you need to print area, height and length. So kena ada lah area, height and length. Otherwise you just put area je kan. Okay, this is the calculation involved. Okay, this is the default default kan. Define height and length as constant. Define height and length as input value, and then put the star in front of the input value. Okay, because we want this value can be changed throughout the program. Okay, so this is not IPO, this is PAC. PAC So this is the IC. Okay, you may put like this. Name is up to you as long as it represents the program that you want to develop. And put control indicating that this is the main module. Okay, you must have control in all your IC. Okay, doesn't matter if you put the name, what name, but you should put control at the end of the program name. Okay, basic, read, calculate, print module. If you couldn't think of any other module, basic you must have is read, calculate, print. But let's say if the program doesn't have calculation, don't put calculation. Okay, let's say the program is just input and output. Okay, input 5 numbers and print output of 5 numbers. Mana ada calculation kan? So just remove the calculation lah. If the program doesn't have any calculation, jangan letak situ pula, salah lah. Okay. Okay, so simple IC and then move to the IPO lah. Okay, so IPO have height, length as the input. So all the input, okay, define the process. Okay, so process should reflect the process lah. If input, you must use the keyword for input. Enter or input, you may put input height, input length, also correct. Okay, and calculate. Okay, calculation, you may just put calculate area or you may copy all the equation and put it over here. Ini salah ni. 1/2 kali height. Formal equation Salah Salah. Betulkan kat situ. Alright. And then display. Okay, again, this is the keyword. Keyword for output process. Display, print. Okay. And lastly, end. Okay, modul. Jangan buat macam ni. Modul ni jangan letak number lah. Letak name of the module. So refer back to the IC. Okay, so read, calculate, print kan. So this is read. Calculate calculate CLC kan. And then print. This one and should be what? Should be what class?
Call area control.
Yes, correct. Control Count area control. So it will return back the process to the main module. Okay, so this is only one area kan. Let's say we added height and length tu. So make sure you didn't miss that one lah. Okay, display height. Display. Ini kena tambah lah. Print height. Ikut kalau udah besar Okay, finish. Okay, there's another example over here that you may look at. Okay, example to calculate distance. Okay, to convert this miles to kilometer kan. Okay, construct a program to be able to convert from miles to kilometer kan. So this is the PAC, this is the IC, so this is the IPO. That's it. Okay, that's all for today. Any question?
No, sir.
Senang kan? Okay, so next week we are going to continue with this then the following steps in designing a program. We are going to focus on pseudo or algo or flowchart, and then dash check for algorithm. Alright, if no question, then sebaik saya tak lupa, please fill in the attendance, and then you may buatlah apa-apa yang patut kan. Okay, thank you again for coming. Okay, see you guys next week. Assalamualaikum.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank
you, sir.
Waalaikumsalam. Thank
Thank
you,
you, sir.
sir.
Thank you, sir.
you, sir.